Hello and welcome back to our next lesson in our physics unit on forces in motion. This lesson is all about electromagnetic forces. Our learning intention for today is to describe the factors that affect the strength of a magnetic field produced by an electromagnet and to research some potential uses of electromagnets. What I need you to do is I do need you to, in your notebooks, write down the title, Electromagnetic Forces, add the date, okay? This is all on page 17, all right? And then I need you to write the learning intention down, okay? So pause the video, write that down, and then you can continue on. Okay, once you've got the learning intention written down, the success criteria for today is to be able to explain what an electric charge is, what an electric current is, what a magnetic field is, and what an electromagnet is. Then you should also be able to determine the factors that increase the strength of an electromagnet. To start out with, for the science starter, I want you to think back to the lab that you just did on electromagnets, and I want you to think about what was interesting about that experiment, okay? What interesting observations did you make about the electromagnets? What worked? What didn't work? Did wrapping the wire all the way around over top of itself work, or did you neatly have it laying out kind of like this one here? Okay, so get that brain going and then we'll continue on. So when thinking about electromagnetic forces, we need to think about first electricity and magnetism by themselves. We haven't done a full unit on electricity, but an electric charge is really what gives us the ability to have electricity. Okay, so in your notebooks, in the Cornell notes, electric charge needs to go in the key terms section, so that small column to the left, and then you need to put the information in the larger notes column. So an electric charge is a positively charged atom or a negatively charged atom. Basically, it means that the atom is no longer neutral, that it is either more positive or more negative. For example, we have here, okay, don't worry about the spellings at the bottom. We have a neutral atom because if you look, how many positives are there? 1. How many negatives are there? 1. So if you have 1 positive and you have 1 negative, what does that equal? 0. Okay, so it's a neutral atom. There is no net charge. Now I'm just going to change the color of my pen here. And we're going to look at the positive atom. So it's written in French, positif. Don't worry too much about that. Just change the F for a VE at the end. Okay? Looking at this positive atom, how many positive charges do we have here? Sorry, I had a little bit of a mix-up with the screen. Okay? We have 2 positive charges. And how many negative charges do we have? 1. Okay? If you have 2 positives and 1 negative, that gives you a net charge or an overall charge of positive 1. So this is a positive atom. All right? And the very last one, over here, the negative atom, we have how many positives? 1. We have how many negatives? 1, 2. Okay? So if you have 1 positive and 2 negatives, if you add them together, you are going to get -1, which is a negative net charge, okay? Positive charges, woo! So the next piece after we've got whether we've got positive or negative atoms and whether we have an electric charge at all is the idea of electric current. You were using batteries. To have a battery and create an electromagnet, we had to create what we call a circuit, which is that connection all the way around with the wire, okay, to both positive and negative sides of the battery. What that connection does and what that circuit allows you to do is to have an electric current pass through, or allow the electrons, the negatively charged particles that give us electricity, it allows them to flow. Okay, So an electric current is made up of electrons. It's described as the flow or the movement of the electrons. Okay, basically the electrons are going to leave one side of the battery, represented by these lovely arrows here, okay? And it's going to flow through or move through the electromagnet, okay? Now, it actually starts here. This is the symbol that we use in scientific diagrams for batteries, okay, with the shorter side being the negative end and the longer side being the positive end, okay? And then we show the wire using straight lines. We have not gone into how to draw a scientific diagram of a circuit, so don't worry too much about that part, okay? What you need to know is it's kind of like a river, actually. We talk about a river current or an ocean current, and what we're talking about is we're talking about how the water is moving, okay? So how is the water flowing? It's the exact same thing for electricity, just we're talking about electrons instead of water, okay? Oh yeah, make sure also, anytime you see this lovely notebook symbol, that means that this needs to go into your notes, okay? So pause the video for a second, add it to your notes, and then keep going. Okay, so the next piece that's going to go into your notes is the magnetic field. And the term magnetic field basically refers to the invisible space all around the battery, or not the battery, sorry, the magnet, okay? All around the magnet where the force of the magnet can be experienced. So what's interesting is that magnetic force can be a non-contact force, meaning that it exists even if the magnet itself is not in contact with the object, okay? And that is because there's a magnetic field that's produced. It starts on the negative end of the magnet and circles around in 3 dimensions all the way around, okay, on all sides to the South Pole. Okay, what you'll notice is that the magnetic field is going to be the strongest on either pole. Okay, so the North Pole and the South Pole have a stronger magnetic field than you have on either of the sides. Okay, and this means that the attraction force or the repulsion force is going to be stronger on the poles as well. Okay? And yes, the two forces are attraction and repulsion. So please write down this in your notebooks as well, and then carry on. And the last piece, I believe, I have to double check, but the last piece I believe that's going to go into your notebooks is what is an electromagnet. And you need to add what's highlighted here in white into your notes as well. An electromagnet is a type of magnet produced by an electric current. The interesting thing is that an electromagnet can be turned on and turned off, whereas a regular fridge magnet or a bar magnet or a horseshoe magnet, they are what we call permanent magnets. That means that they are always magnetized. We cannot turn them on or off, okay? So an electromagnet we can turn on and off. As an additional description, we have some extra information that you're welcome to add into your notes, but is not necessary. I would actually recommend that you maybe draw an electromagnet into your notes section, okay, so that you have a picture of it to think of in your mind. But basically, an electromagnet is a piece of iron or another conductive metal, such as steel, that's wrapped with a coiled insulated wire. Okay, when the current passes through the wire, the core, so in this case, the nail becomes magnetized, and this creates an electromagnet. Electromagnets can come in various forms, not just this simple form, but this is probably one of the most simplified ones. Okay? So copy that down and then keep going. So when you are looking at the presentation itself, you'll be able to click on this link to watch the BrainPop video. I do recommend watching the BrainPop video. It is very good and goes into a lot of detail of things that are important with a magnet, such as the orientation and how the magnetic field can affect how the forces are occurring. Okay, and we want you to think about these 3 questions while you're watching the video. How does the distance between objects affect the electromagnetic force? How does the orientation of 2 interacting objects affect electromagnetic force? And what other factors can increase or decrease the electromagnet's strength? Okay, if you're not sure, the password, well, the username for BrainPop is Dubai. Okay, it might be a capital, it might not be, I don't remember. And then the password is PopLearn. Okay? So that brings us now to what factors affect the strength of an electromagnet. We're going to go through a series of questions here. And what I'd like you to do is I would like you to try to think of the answer. We're going to discuss them in class if you're in 8H. Okay, we're going to discuss them in class the next time that we meet. We're going to start with these as our starter. All right, but which electromagnet is stronger and why do you think that? Okay, so take a minute to have a look at this picture. Is it electromagnet 1 or electromagnet 2? Be prepared to explain your answer, okay? Same question, but a slightly different picture. So look closely at these 2 magnets. Okay, and again, you need to explain which one you think is stronger and why. Make sure that you're thinking back to the experiment that we did on electromagnets to really use your observations and what you learnt through the hands-on experience to explain your answer. Okay, one more. Does it matter if the coils are tightly wrapped or loosely wrapped? Okay, which one do you think is going to be stronger? And again, why? And then what happens if we replace the iron nail, pictured on this side over here on the right-hand side, with wood, okay, or with a pencil? Which one would be stronger and why? And some of you did try this with the wooden stick for the electromagnet, so use what you had seen to try and come up with your answer. All right, I forgot about one last slide. So one last thing to write down in your notes. What needs to go into the key terms section is the factors that increase the strength of an electromagnet. And there are 4 things that you need to write in the notes section. Okay, wrapping a wire coil around an iron core is 1. Adding more turns to the coil, okay, so here 200 is going to be stronger than 50, okay? Creating tightly wrapped coils, so having them closer together, and increasing the current through the metal coil. In our experiment, we did this by having more batteries, okay? And then the next thing that we're going to look at is why do we even have electromagnets? What's the point of having them? What can we do? How are they used? Okay, you'll need to open the presentation itself to be able to watch the video for the maglev, but the maglev is the fastest train in the world. Okay, 361 miles per hour, which I believe when I calculated it out is approximately 580 kilometers per hour. Okay? This is extremely fast. I think you'd reach, I mean, I haven't done the calculations, but you could probably reach Abu Dhabi in like 15 minutes. Okay? Or less. Maglev stands for magnetic levitation, which is what the train uses to go so fast. And by levitating, it actually decreases the friction. So it's reducing the amount of force from friction, and then that increases its speed. It doesn't need as much force to be able to travel as fast. Okay? In these trains, there actually is no engine, so it's different from a typical train. It's magnets on the track that make it levitate by pushing it up off the track, and that attract and repel to make the train move forward, to propel it. Okay? Again, I do strongly recommend watching the video by clicking on this link. So what you need to do on page 16 in your notebooks, okay, is to research one way that electromagnets are used in everyday life. You need to answer a couple of questions. Okay, so you need to answer, why is it useful to have a magnet that can be turned on and off? And you need to describe how the electromagnet is used, draw and label the diagram showing how it works, and be ready to show that in class. I also recommend that in your drawing or your diagram that you add some color. Okay, we've got a couple of examples here, and on the next slide, there's some more links for other examples of electromagnets. We've got the scrapyard use, maglev trains, MRI machines in the hospital, along with, if you watch the Brain Pop, you'll know that any sort of motor, vacuum cleaners, motors, generators, doorbells, speakers, they all use electromagnets. So pick the one that's most interesting to you. Okay, and then as the exit ticket, you do need to complete your summary. In your Cornell notes on page 17, you need to write 3 important facts that you learned about in today's lesson. And those links for you, lots of links on electric motors, electromagnetism, electromagnets, all of that sort of stuff are here in the extension. So open up the presentation itself and you'll be able to click on all of these.